Hey guys, it's me Chiku from Chiku Study Corner, and today we'll be dealing with a new chapter, that is Coordination Chemistry. So that is a chapter of Chemistry Class 12 CBSE. So without any further ado, let's get into the chapter. So in this chapter, what all you will learn is something that is very new to you, because you haven't learned about Coordination Chemistry in class 11th. You're learning a new topic. So listen carefully. So now let's take first some examples of coordination compounds. So let's write coordination compounds. So let's take the examples. Example. The first one which we are going to write is K4FeCN 6 times. Okay? That is our first coordination compound. The second one that we are going to write is FeC2O4 and the whole in square bracket and 3 minus. Okay? Let's take one more example. So the last example is NiCO4 times the square bracket. So in this, I wrote 3 examples. Out of these 3, can you see something that's common for all of that? That is the square bracket. Everything has a square bracket. Am I right? These square brackets would help you determine whether this is a coordination compound. The coordination compounds would have a certain term which is always in square bracket. There's an exception. That is in the case of CO. Okay, this is nothing. If it's CO, what is CO? It is not cobalt, it is carbon monoxide. If carbon monoxide is taken into consideration, it can be written with or without a square bracket. That's the only special case that we have to learn. Special case that we have to learn. So, now we discussed about what? These examples. You can see some difference between these two. No? Over here, can you see anything outside? No. Over here, can you see anything outside? Over here, can you see? Yes, K4 is there outside. So let's see the detailed explanation of what is a coordination compound. So, I'm rubbing these examples and I'm just writing only the first one. So, let it be. This is our first example. K4FeCN 6 times. So, let's see. Now I told you can differentiate this coordination compound alone into 2 different terms or 2 parts. What are they? With square bracket and without square bracket. Am I right? So which is with square bracket? That is, this term is with square bracket and this is without square bracket. So now you see, if you take, my name is Diya, Maran, Jacob. You can split it into 3 parts. Yeah, Diya, Maran and Jacob. In the same way, I'm not just telling I have 3 different, like this is my first name, second name and third name. No, I have specific names for these positions. First name is Diya, second name is Maran and third name is Jacob. So, let's see. Over here, I told you can divide it into 2 parts. Which all are they? One with square bracket and one without square bracket. So, each of these have a specific name. So, the one with square bracket is either called as coordination sphere or coordination entity. Get it? So, what is this? Coordination sphere or coordination entity. So, if you are asked to define what is coordination sphere, the definition would be, that is the term the atoms or molecules which are put inside a square bracket is termed as what? Coordination entity of a coordination compound. So, anything that is enclosed in a square bracket, in this is its coordination entity. So, over here this term is the coordination entity. So, we name this part. So, what would be this? This is called as counter ion. Okay? Yeah, this is counter ion and this is coordination entity. This is the general structure or in the basic level. I just said what is a coordination compound. So there is something more you have to learn. There is so many terms that is related to this. So the first two terms that we learned is coordination sphere or coordination entity. The second one is counter ion. So let's see the rest of them in detail. So this counter ion is either positively or negatively charged radical. So what does this do? This can be either positive or negative, I told you. So counter ion, I'll rub this in right. Counter ion can be positive or negative. If it is positive, it's written on the left hand side, okay? And if it is negative, it's written on the right hand side. So for example, if this is our coordination entity, our counter ion, if positive, will come here, or if negative, will go to the other side. Okay? So this is the to talk about counter ions. So now let's learn this compound or this entity alone, that is the coordination entity. So let's take the same example and we'll continue. So K4 FeCN 6 times. Okay? So let's see. Over here we are just considering this entity alone. So let's rub K4. Yes. So over here also you can see there is two combination of two atoms, or there's two different molecules over here. There is Fe and CN6. So this Fe is a metal. Usually in a coordination entity, there is a transition metal. It's usually a transition metal. So what is that? This is a transition metal. And this transition metal is called as what? Central metal atom. Okay? So what is this? This is central metal atom. And over here, the rest of this is called as ligands. So let's see what central metal atom is. So what is a transition element that has outer orbitals? Yeah, that's free outer d orbitals. That's what is transition metals. So let's write central metal atom. So for central metal atom, first thing I told you is it's a transition metal. Then what did I tell about transition metal? Free d orbitals. So since this has a free d orbital, what is this? This is a Lewis acid. Because this what? Okay, we'll write the example over here. This I'm only just writing the entity. Okay, I'm just writing the entity. That is FeCN 6 times. So what is this? The cyanide molecules would give what electrons to Fe. So what is this? This is an acceptor and therefore it's a Lewis acid. Okay. So it's a Lewis acid. So if this is a Lewis acid, I told you what would be this entity. That would be a Lewis base. So let's see what is this entity. So this entity I told you, the name is what? Ligands. Okay. So ligands. So what is ligands? Ligands are molecules that are directly linked to the central metal atom. So directly linked to central metal atom. Then what is the second point? It is a Lewis base. Okay. So this is a Lewis base. These ligands are attached to the central metal atom. What is central metal atom? A Lewis acid. I told you these compounds, what are they? This is Lewis base. What? Ligands and Lewis acid are a central metal atom. Central metal atom accepts a pair of electrons from ligands and form the coordination bond. Okay. So what is that? They accept electrons from ligands. The central metal atom accept electrons from ligands and from what coordination? Coordinate bonds. Okay. So now let's see what is denticity of a ligand. So let's see what is that. Denticity. Not dentistry, it is denticity. So denticity of a ligand is the number of donor atoms in a ligand. Okay. So number of donor atoms in a ligand. So before I telling you about this, we didn't discuss about the examples for ligands. So let's see the examples. So the examples are NH3, Cl minus, C2O4, H2O, En, etc. etc. There are so many examples. So I'll give you a table. You have to by heart the table, because for examination, if you have to do the nomenclature, you should know about this. Okay, the names of these have special names: amines, chloride, chlorato, and etc. There are so many names. So let's see one by one in detail when we go through the chapter. So number of donor atoms in a ligand which are directly bonded. Okay, this is an example I just mentioned, which are directly bonded to the central metal atom. Okay, so this is what is denticity. So we have to learn about a few types of denticities. So let's see what all are they. We have to learn about monodentate ligands, bidentate ligands, tridentate ligands, chelating ligands, etc. There's a lot of them, from which we only learn a very few of them. So let's see first what is unidentate ligands. So to talk about the denticity, I told you there are different types. So the first one is unidentate or monodentate ligands. So let's see. Uni or mono. What do you mean by uni or mono? That is one. And what does that mean? There is only one donor atom that is directly linked to what? Central metal atom. Okay, so this is what is to talk about uni or monodentate ligands. So the example is NH3 and H2O. See, there's only one atom. See, there's NH3 only, and over here what is that? H2O only. So let's see the second one, that is bi or didentate. So bi or tri. Sorry, bi or di. I'm sorry. So let's see what is bi or di. Over here, what is this? What does these term mean? This means 2 implies what? There is 2 what? Donor atoms. Am I right? That is directly linked to central metal atom. So what is this example we'll write? The first one is C2O4 oxalato. So see, how does this look? COO minus COO minus, it is linked. So what is that? You can see there is 2 donor atoms. C2O4 has 2 donor atoms. Likewise, example is En. What is En? En is ethane 1,2-diamine. Okay, what is that? Ethane 1,2-diamine. Okay, so now let's see about polydentate. We don't have to learn about tridentate, we have to learn about polydentate ligands. So over there we have to learn what the ligands with 6 denticity. The denticity as 6. So let's see. That is the only thing that we have to learn for our school board exams. Okay. So polydentate. What do you mean by poly? That means more than 2. Okay. More than 2. So we have to learn about the one with 6 as denticity. So let's see. what do you call something with 6 sides? Hexagon. So what would be this? Hexadentate. Hexadentate. So let's see the example for an hexadentate. That is EDTA is an example for what? Hexadentate ligands. So let's see what is the structure of EDTA. So EDTA is called as, I'll write, ethylene diamine. Then it's because there's no space. Tetraacetate. Okay, so ethylene diamine tetraacetate is the name for EDTA. EDTA 4 minus. Okay, I forgot to mention it's 4 minus. So let's see the structure of EDTA. So what is EDTA? It is also a ligand, that is hexadentate ligand. Okay, that is its denticity is 6. So let's see the structure. CH2N, then what is that? CH3COO and CH3COO. Over here again CH2N, it goes like this, the bond goes like this, CH3COO and CH3COO. So what all are the, we learned for NH3, what was our donor atom? That was nitrogen. So anyway, nitrogen is a donor atom. So this is how many of them? This is single entity. So over here itself it is 1 and 2. Yeah. And O minus is also a donor. So what is this? This is 3, this is 4, this is 5 and this is 6. So what is this? There are 6 donor atoms in this ligand, and therefore it's called as hexadentate, and the short name is EDTA for this example. This is an example of EDTA, ethylene diamine tetraacetate. Okay, 4 minus, because we have 4 oxygen. So that is to talk about what is polydentate ligands. So now let's see about ambidentate ligand. So let's see what's ambidentate ligand. So, have you heard of the word ambivert or let's say, yeah, what is ambivert? That lies between both extrovert and introvert. Like likely to be okay. You talk to the society but not too much, nor you're silent. That is ambivert. It is in between. The same way, what would be ambidentate ligand? So, let's write. Ambidentate ligand. What would be that? These are monodentate ligands who has what? 2 donor atoms. So what? They are unidentate but possess what? 2 donor atoms. So you might think, how is that? That's a bidentate. How can you call it a unidentate? But over here, even though there is 2 donor atoms, only one out of which would work at a time. Okay? So what is that? Only one at a time would work. Only one at a time will act as a ligand. So the example is NO2. That can be NO2 itself, or NO2 itself, or what? ONO. So over here what would happen? This would become the donor atom, and over here this is the donor atom. Okay, so you can see that there's 2 different types of ligands over there. So actually NO2 is a ambidentate ligand which can act as NO2 or ONO minus. So let's see. Next example that we have to learn is what? CN. Okay? About CN, that is cyanide. Before that, don't you want to know the special names for each of them? This is nitrito N and this is nitrito O. So what is this? Nitrito N and this is nitrito O. Okay. So now let's see the example of Cn. So Cn is split into Cn minus or Nc minus. So this is called as cyanido. This is known as thymocyanado. I'm sorry, it is not thymocyanado. It is isocyanado. Isocyanado. Okay, these are the two examples for ambidentate ligands. So now we have to learn about something known as chelating ligands. So what is chelating ligands? Let's see what's chelating ligands. Chelating ligands. Let's see what's chelating ligands. When a polydentate or an ambidentate ligand comes, and what would happen? They would form cyclic or ring structures. This formation of cyclic or ring structures is called as what? Chelation. This process is called as chelation, and the compound form is known as chelate, and that kind of ligand is known as chelating ligand. Did I confuse you? What is this? This process, the process is called as chelation. Okay? Then what did we learn about chelates? The formed structure is called as chelates. And this kind of ligands are known as chelating ligands. Okay? So now let's see an example. So before discussing about an example, let me tell you, this chelating ligand is very stable because it forms a cyclic compound and hence have a stronger bond. So what is that? I'll write. These complexes are more stable than unidentate or bidentate ligands. Did you get me? So what is that? These complexes, these chelating ligands are much stronger, or they have a much stability than that of what? Both unidentate or bidentate. Okay? So now let's see the next one. That is the structure. So the example that we are going to take is COEN3 square bracket 3 plus. So let's see. So this would be like, what is our central metal atom? We have En. Okay, let En be there. What is our central metal atom? Cobalt. So let's draw cobalt. CO. And I told you it forms a cyclic structure. So let's see what is that. I'm just rubbing this because I need some space to draw. So cobalt, what is that? Let's draw the structure. Over here we have NH3. Over here also we have NH3. And then over here we have what? CH2, and over here we have CH2. Isn't this a closed cyclic structure? The same way it will be over here also. NH3, NH3, and it is connected to CH2, and this is the one over here. Over here also the same thing. NH3, CH2, done. So this is the structure. This is the cyclic structure. And how do you mark the charge? I wrote 3 plus. Either you can put a whole square bracket or half square brackets and write 3 plus. Okay, this is how you represent or you draw a chelating ligand. So the last topic of this video that we have to learn is about the the homolyptic and heterolyptic compounds. So what is homolyptic and heterolyptic compounds? Let's see. Homolyptic or heterolyptic. So what do you mean by homo? Homo means even or equal, or what do you say? They don't have any difference, whereas hetero is different. So what is homoleptic complexes? They are complexes that have only one kind of ligand in them. So the first example that we learned, K4FeCN 6 times is an example for homoleptic complexes because there's only CN6 over there. So what is this? What is a homoleptic complex? That has only one kind of or only one type. There is 6 of them. That doesn't matter. It is only one type because there's only Cn minus. There is no Br, there's no I, etc. Only this is called as what? Homoleptic complexes. So now we'll see the example of heteroleptic complex. So heteroleptic complex, we'll take Pt, that is platinum, then chlorine. Sorry, why am I putting a comma? There's no comma. Okay, chlorine, B, R, F and I. These are all in a square bracket. Over here, how many of the ligands can you see? Pt is a transition metal and therefore it's a central metal atom. You can see chlorine, bromine, fluorine and iron. So what is this? These are all what? Different kinds of ligands. They are not the same ligands having different, repeated. This is over here, it is Cn 6 times. It is over here what is happening? Cl, Br, F and I. They are different complexes. And therefore, what is this? This is a heteroleptic complex. So what is this? This is a heteroleptic complex. So friends, that's all for today's video. I hope you might have understood it and liked it. If you've understood it and liked it, please give my video a huge thumbs up and also subscribe to my channel if you're new there. And also share my video with your other friends. So see you on my next video. Till then, bye-bye.